Verify that the wave function psi x equals c exponential minus m omega x squared over 2h cross is an eigenfunction of the simple harmonic oscillator with energy half h cross omega. Find the value of the normalization constant c. So we need to first write down the Schrodinger equation. So the Schrodinger equation, let me write down. Is given as follows. So h psi equals E psi, and this is the left hand side is the Hamiltonian operating on the wave function psi. So let us find out first the left hand side. For that we need to evaluate first the second derivative of the wave function, and for now I will ignore the constant c, because that will remain constant throughout and it will come out of the derivative and it will be present in each of these terms in the Schrodinger equation. So it will cancel out. So the second derivative of essentially what we need to find out is the exponential. So second derivative of the exponential. So derivative of exponential remains the exponential and the constant term comes out. So let me just replace, because this m omega over 2h cross, let me replace that with a, where a is just a constant. So a is m omega over 2h cross. So this is, so first we will find out the first derivative. So that's the first derivative, and now the second derivative. Sorry, I made a mistake. We will make use of the chain rule of differentiation. And now we will make use of product rule of differentiation. So this is the first term in the Schrodinger equation. Now let us write down the left hand side of the Schrodinger equation. Again, I am going to ignore the constant and only consider the exponential term for the time being. And plugging in the expressions. And now we are just simplifying. Sorry, I forgot to write x squared over here. And this whole thing multiplied by e to the power minus ax squared. Now a was a constant which we had defined. So let us plug back in the expression for a. And now some terms will cancel out. Let's see, h cross here cancels out with h cross over there, and over here as well we have h cross squared in the numerator cancelling out with the denominator, m over here, and this 2 factor as well. So finally we are left with so this second and third terms also cancel out. This cancels out with this, and this is nothing but psi without the constant c. So we are left with which is equal to E psi, because E we are given is half h cross omega. We are given the energy is half h cross omega. So this means that the eigenfunction psi satisfies the Schrodinger equation. So it is an eigenfunction of the simple harmonic oscillator. Now we will move on to the next part wherein we need to find out the normalization constant. So the normalization criterion, let me write down. Is given as follows. Integration over the entire space, so x going from negative infinity to infinity, this should be equal to 1. This is the normalization condition. Now in our case, let us write down. So in our case, psi is c e to the power minus ax squared, where a is again the same constant, m omega over 2h cross. So let us find out this integral. Psi star psi dx. So this is, let me write down explicitly, c star e to the power minus ax squared c e to the power minus ax squared dx. Now this is the Gaussian integral, and Gaussian integral we know, let me write down the identity. So for Gaussian integral, we know that the following integral this is the Gaussian integral, so we will make use of that. So this then comes out to be root pi over b in our case is root 2a. So root 2a. So mod c squared square root pi over 2a. This is the integral. Now for this to be equal to 1, we get mod c squared equals to 2a over pi and let us now put in the expression for a. A is m omega over 2h cross. And then this 2 cancels out. So our normalization constant is then m omega over 2h cross raised to the power 1 over 4. This is the normalization constant for the wave function for a simple harmonic oscillator. So in this question, we verified that the wave function of a simple harmonic oscillator is of this exponential form, and we also found out the normalization constant for the same.